All right, guys, here's a video lesson for 12-4 on angle measurements and segment lengths in circles. Some of these drawings get increasingly a little bit more difficult with the circles, but I'll do the best that I can. But I'm going to encourage everybody to please read through this section in your book for some additional information and understanding. All right, Theorem 1213. If you've got a circle, and that circle is cut by two different lines. Notice that it's not in the center, okay? So you've got an angle formed by two lines that intersect inside a circle, okay? What you end up with is this is angle 1 here. This is the measure of the arc on the outside in y degrees and the arc on this side in x degrees. Okay, so the math rule that's found is the measure of angle 1. So the measure of that angle, it is not a central angle. Please keep that in mind. The measure of angle 1 is always half the measure of the two arcs that it forms on opposite sides. So you add x plus y in terms of degrees for the arcs, and then you cut it in half, and that's the measure of angle 1. Okay. A little bit different is Theorem 12-14. I'll do it on the same screen so you can see both of them. So here we've got another circle. Now we've got two lines that intersect outside the circle like this. Okay. In the first case, if you take x degrees here, and I'll state the rule as I put it in here. Here is the measure of angle 1. So there's angle 1 right in that. And then y degrees is here. Having trouble getting my stylus to completely right here. So there's y, here's x over here. All right, so now look at this. The measure of angle 1 here, the angle that is formed outside, is the sum, or excuse me, half the difference. It's equal to half of the larger arc minus the smaller arc. So in this case, it'd be half of x minus y. And that applies even if you have tangent lines. Even if one of these lines was here and you had one tangent and one non-tangent, or if both lines had been tangent like that, the rule would still apply. But let's go back to the basic normal setup. Basically, let me go ahead and read it one more time while looking at the picture. The measures of an angle formed by two lines that intersect outside a circle is half the difference of the measures of the intercepted arcs. So here's one intercepted arc here where x is. Here's the other intercepted arc. And those arcs are intercepted by both lines. All right, so that's Theorem 1213 and 1214. You can see the mathematical applications from both. You might take a picture like this and put it in your notes as something that you'll want at hand when you're taking this test, because you're going to want to see those formulas about what that measure of that angle is. Erase all of these. All right. So here's a problem. Here's the problem in problem number 1. It's asking for the value of each variable. So here's one problem. We've got a circle here. We've got two segments that cut across the circle here. And we've got x degrees here. And then we've got a 46-degree arc out here and a 90-degree arc here. Now, key thing to note is it's not in the center. If it was the center, if x was a central angle, then x would be equal to 90. Instead, x is equal to 1/2 of the sum of those two angles, which is 46 plus 90, or 1/2 of 130. I can't get my 3 to write very good. 136 there. So that would be x is equal to 68 degrees. All right, so there's one example like that. Let's get an example of 1214 as well. 1214, slightly different. In my estimation, 1214 can be a little bit more confusing, so just be careful of it. All right. Now we've got another circle. Here you've got the intersection. One is tangent. The other comes across right there. They intersect outside the circle. We know that that right there is a 20-degree angle. This is z degrees, and this is 95 degrees. Okay, it's pretty obvious that the 95-degree arc is the bigger arc, so that has to be my x in my calculation. And so my 20-degree angle is equal to my larger angle, 1/2 of my larger arc minus my smaller arc. All right, so we're going to distribute, and we're going to get, actually, let's just multiply both sides by 2. So we don't have to deal with a decimal. And you've got 40 is equal to 95 minus z. Subtract 95, and you've got a negative z is equal to a negative 55. So z is equal to 55 degrees on that smaller arc. All right, so hopefully you can see how that works. Not too difficult. And then that leads us to the final theorem, which is theorem 1215. Let me check how much time I've left. Just about halfway through, so that's perfect. All right, got it all. All right, so here's the idea. For any given point and circle, the product of the lengths of the two segments from the point to the circle is constant along any line through the point in the circle. That is a big old statement, and it's a little bit hard to understand. They give 3 examples. Okay, so here's a circle. If I cut through here, and here's point P, where it intersects, then I've got another one here. Again, please note, it's not through the center, okay? So here's point P right there, where those two intersect. And then they've labeled all these segments that have been cut. This one's cut into A and B. That's a B right there. And then that is a C up there and a D down here. All right. For a given point and circle, the product of the lengths of the two segments from the point to the circle is constant along any line through the point and circle. So the product of A times B is constant and equal to C times D. It's just in the way circles work. It's the way circles work in these circumstances because there's constraints, because that circle has a defined distance from the center. So these segments that are inside the circle have these patterns that always are forced. All right, let's try another one. In this circumstance, What if we've got one line that cuts through the circle and another line that also cuts through the circle, and they intersect outside the circle? Okay, so let's label some segments. X, so there's W and X, and here's Y and Z right here. Okay, it's still the same idea. In this case, W plus X. Okay, whoa, got that little parentheses wrong there. W plus X in parentheses times W is equal to Y plus Z in parentheses times your Y. Okay. Basically, it's a ratio that's established. It's a slightly different ratio because you've got W and Y outside the circle. So you have to multiply both by W and Y. And then finally, you've got one other example with some tangent lines. So here's our circle. Here's one tangent, and it intersects this one that is non-tangent outside the circle. So we've got a tangent line and we've got a non-tangent line, or line segment, I guess I should say. There's Z, there's Y, and here is T. They label that one as T. All right, so in this case, T times itself, or T squared. Notice they just go straight to T squared. If you want to make it look like the others, you can do T times T. That's where the T squared comes from, is equal to Y plus Z in parentheses times that Y section that's outside. Okay? All right, you're just going to have to kind of memorize 1215. So the products of the chords in this one, part 1, is what it's labeled here. So we'll use a Roman numeral 1 if I can get my stylus to work the way I want to. So in that one, the product of the two chords are equal. In this one, you have the product of the secants and their outer segments being equal. Okay? We hadn't really defined a secant. That's a definition that I missed from an earlier section. I can't remember which section it came up, but I guess I ran out of time to go through it and was wanting you to read it. But you have the product of the secants and their outer segments are equal. So here's secant, and then these are the outer segments, W and Y. And then finally, case 3. I already talked about how you've got, in this case, one tangent line. You have the product of a secant and its outer segment, which is Y plus Z times Y, is equal to the square of the tangent. Because they list that in the terminology, I guess I will go ahead and put T squared. And it's just another rule that you should copy these figures into your notes and have them available for the test. It's a fairly easy apply as long as you're looking at the pictures and you know it. I'm at 14 minutes, so about out of time. So I'm going to let you use these figures to handle all the problems on Math Excel. I see some have already started it, so I think you're doing a great job of letting the book kind of guide you on this. Luckily, the Math Excel is created straight from the book, so there shouldn't be any curveballs, but there may be a few harder problems. So let me know in tutoring tomorrow if you need. Remember that this assignment is due at 4 o'clock on Tuesday. Take care and hope to see and talk to you all soon.